Hey guys, following our lesson yesterday on adding and subtracting, we're going to, as you can expect, follow with multiplying. We are not going to divide until we get to rationals, if we get to them. Otherwise, you will get to them in either Algebra 3 or Pre-Calc, depending on what you take next. So we start off, we've got 6b times the quantity of 2b plus 3. You should already be considering distributive property, considering how many of you want to use distributive property whenever you see parentheses, regardless of whether you can combine what's inside. So when we do that, we're going to take 6b times 2b, and I'm going to write it out, which I want you to do as well, plus 6b times 3. And then we start multiplying out. 6b times 2b, remember that's 12. 6 times 2 is 12. b times b is b squared.
Remember to take a look at it as b times v and not two b's.
Yes, there are two of them, but that's why it's b squared. And then 6b times 3 is 18b. We cannot, I repeat, we cannot combine 12b squared and 18b because they are not like terms, which leaves us our answer. The next one, this should be bringing back flashbacks to Algebra 1. We are going to FOIL. So first outer inner last, so the first terms multiplied together, so 2n times 6n. Then outer terms plus 2n times 1. And then we've got the inner terms plus 2 times 6n. And then the last terms plus 2 times 1. And then we combine, start multiplying out. So we got 2n times 6n, which we said is 12n squared, but last time it was a v. 2n times 1 is 2n. 2 times 6n is 12n. And 2 times 1 is 2. And then I look and I say, oh my goodness, I can combine 2n and 12n, giving me a final answer of 12n squared plus 14n plus 2. All right, now 4p minus 1, the quantity squared. This is where a lot of you guys get yourselves in trouble. If you think back to Unit 1 when we were talking about exponent rules, which we'll get to reviewing some of those in a little bit, a lot of you guys kept saying we're going to distribute the exponent. We do not distribute an exponent, because this is where it gets you in trouble. If you remember, if we have 3 squared, 3 squared means 3 times 3. Likewise, if we have x squared, if you go back to A, when we had v times v, that was v squared. So we've got x times x. That means when you have 4p minus 1, the quantity squared, this really means 4p minus 1 times 4p minus 1. And then you have to FOIL. So 4p times 4p, 4p times negative 1, and then we got negative 1 times 4p, and negative 1 times negative 1. So then we can start multiplying out. 4p times 4p is 16p squared. 4p times negative 1 is negative 4p. Negative 1 times 4p is negative 4p. And negative 1 times negative 1 is positive 1. And then when we combine our like terms, we get 16p squared minus 8p plus 1. If you had just distributed the exponent, you would have gotten 16p plus 1, and you would have missed that middle term altogether. So, let's do a little bit of a review of our power of powers rule now that we had that opportunity. When we are multiplying exponents with the same base, you add those powers. So this would be x to the 5th. Because remember, x to the 3rd is x times x times x. And x squared is x times x. We got 1, 2, 3, 4, 5 x's. Now, x to the 4th all to the 5th, we are going to multiply, so x to the 4 times 5, which would be x to the 20th. And the reason why that works is because x to the 4th to the 5th is x to the 4th times 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 x to the 4th, which if we wrote all of those out, we'd have 20 x's sitting there. Now, that being said, it's because we're getting into some more heavy-duty work with these two problems here. So this first one, multiple times of repeated distribution. So you've got 2x cubed times 4x cubed plus 2x cubed times negative 2x squared plus 2x cubed times x plus 2x cubed times 3. Now when we start multiplying that all out, 2x cubed times 4x cubed is 8x to the 6th, because 3 plus 3 is 6. 2x cubed times negative 2x squared is negative 4x to the 5th. 2x cubed times x is plus 2x to the 4th. And 2x cubed times 3 is plus 6x cubed. All of those have different powers, therefore leaving us with our solution. Now, I want you right now, if you're listening, to put your pencil down and just watch. I'm going to show you how a lot of you guys are probably going to want to attempt this problem, which then you're going to see very quickly, as you could see in the last one where the line started to get very long, why it's not the best choice to use, because you can get lost in your math. So if I did repeated distribution, I distribute the x to everything, which would be x times x cubed plus x times 3x squared plus x times negative 2x plus x times 4 plus negative 3 times x cubed minus 3 times 3x squared minus 3 times negative 2x minus 3 times 4. I didn't have room to put it all on there. You can see really quickly, you can get lost in your math very quickly. So I'm going to have you pick up your pencil right now, and in about 2 seconds, this whole thing is going to disappear. All right, I'm going to show you a convenient way to organize your thoughts. So I'm going to take the longer one, put it across the top. I'm going to do a lattice method. So we got x cubed plus 3x squared minus 2x plus 4. Down the top and on down the side, I've got x minus 3. I keep the minus with the 3. And I create this beautiful box where every time there's a addition or subtraction sign, I'm going to draw a line. So now I multiply x times x cubed is x to the 4th. X times 3x squared is 3x cubed. X times negative 2x is negative 2x squared. X times 4 is 4x. Negative 3 times x cubed is negative 3x cubed. Negative 3 times negative 3x squared is negative 9x squared. Negative 3 times negative 2x is 6x. And negative 3 times 4 is negative 12. The nice part is that my like terms are right down the diagonals. So now I just have to combine my like terms. So I have x to the 4th. 3x squared, x cubed, and negative 3x cubed cancel. Negative 9x squared, negative 2x squared is negative 11x squared. 6x and 4x is 10x minus 12. And my answer is done. All right, so now that we've got that answer, just as a refresher from yesterday, if we have a sum of f plus g of x, it means f of x plus g of x. If it's f minus g of x, it's f of x minus g of x. When we start talking product now, remember product means multiply, f times g of x means f of x times g of x. It might also be written just with f and g right next to each other instead of separating them with the dot. So when we have f times g of x with f of x equal to 3x squared and g of x equal to 5x minus 2, this really means f of x times g of x, which is going to be 3x squared plus 1 times 5x minus 2, and you can use the lattice box method that I used up above. I'm going to just do a quick FOILing. Now that we've had a chance for some practice, I'm going to do it in my head. 3x squared times 5x is 15x cubed. 3x squared times negative 2 is negative 6x squared. 1 times 5x is plus 5x. 1 times negative 2 is minus 2. And we're done. Now it says f times g of 3. So like I said before, you can put, this one might be a better option. I'm going to show you this. Yesterday I said you can just then take and put 3 in for x into this right here. A quicker, faster option, just because you have all those higher powers, might actually be to take 3 times 3 squared plus 1 times 5 times 3 minus 2, only because they're smaller numbers. 3 squared is 9. 9 times 3 is 27. 27 plus 1 is 28. And 5 times 3 is 15. Minus 2 is 13. Then, if we take 28 times 13, we get 364. Now, this next one, this is f times g of 5 plus f of 4. So we're adding a little bit of challenge into this. So we are going to now have the opportunity, I'm going to go the other route now, and I'm going to put in, we got 15 times 5 to the third minus 6 times 5 squared plus 5 times 5 minus 2. But then we're adding on to that plus our 3x squared plus 1, but it's to the with 4 substituted in, so 3 times 4 squared plus 1. So now 5 to the third is 125. 125 times 15 is 1,875. 5 squared is 25. 25 times 6 is 150. 5 times 5 is 25. We got minus 2. And then we got plus this whole total. 4 squared is 16. 16 times 3 is 48. Plus 1 is 49. Now we can condense this. So 1,875 minus 150 is 1,725. And take that plus 25, you get 1,750. Minus 2 plus 49, and you get a grand total of 1,797. I know that was a lot there to take in, but now we've got you to try this problem. If f of x is 2x squared minus 6 and g of x is 2x minus 2, find f of g of x and f times g of x and f times g of 2. And if you have f of x equal to x plus 2 and g of x equal to x squared minus 4, find g of f of x and g of f of 3. And be prepared to discuss the idea of, does it matter whether you take f of g of x or g of f of x? Will it come out to the same value? And as always, bring your questions with you to class.